Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, thank you.
Yes, sir.
Okay, so just we're waiting 1 minute, then we'll start today's session. Okay, so we will start today's session. So basically today is our fifth number of class, and mainly today's session I try to discuss about that air quality monitoring. Okay, so different types of air quality parameters such as particulate matter 2.5 or nitrogen dioxide, sulfur dioxide or carbon monoxide or formaldehyde. So this type of air quality parameters, how we can easily monitor using Google Earth Engine. Okay, so let me start. So just let me share my screen. After completing the live training, we talk about the problem solving class. Okay, for the previous class, if you have any problem, any doubt, then we talk about that. Okay, so now can you see my screen?
Yes, sir.
Okay, thank you. Okay, so today's session I try to talk about that air quality monitoring. So different types of parameter. We already know about that air quality parameters such as nitrogen dioxide, sulfur dioxide, formaldehyde, then methane. So this type of gases, how we can easily monitor. We also discuss about that, and how to download the air quality parameters time series data in CSV format. So basically this example you can also set for other parameter, not only for the air quality parameters data. Any kind of time series data we can easily download as a CSV file, because we already know about that some time series chart, when you create the chart in Google Earth Engine, we face some problem. So when it across the limit, it show about the lot of pixels, so this chart is not work. So for that we also need to learn about that, how we can easily download the time series data in CSV without creating the chart. We can directly download the CSV file, and further we can easily make the time series chart in Excel file. Okay, we also talk about the time series chart of air quality parameters. Then air quality monitoring, mainly how to calculate the total emission of any specific gases. It can be nitrogen dioxide or methane or sulfur dioxide or any gases. How we can easily calculate the total emission for a specific time period. Okay, we also discuss about that. And then we talk about that AOD. So basically it's the aerosol optical depth. We can also discuss about that. Then we also discuss about the PM 2.5. Okay, PM 2.5, mainly particulate matter 2.5. We discuss about that, and as well as we also discuss about that ArcMap software. Okay, ArcMap software. So basically this ArcMap software we also discuss about that, and how we can easily make using the map layout after downloading the data from Google Earth Engine. How we can easily handle using the ArcMap software, we also discuss about that, and also talk about the accuracy assessment of air quality monitoring map. Okay, I'll also try to explain all of those one by one. Okay, so just a minute. I think some people are not joining yet.
Hello?
Yes, okay. Okay, so we will start after some minute. Okay, so basically some participants are not joined yet. So they face some problem, I think. So that's why I will give them access, then we'll start.
Okay, very good. Thank you very much for that.
Okay, so we'll continue now. So we'll start. Okay. So let me open my slide. Okay, so now we'll start. So let's go. So first of all, here you can see this is the two map. One map is that methane concentration map of web. Another is the nitrogen dioxide concentration map year of 2020 month of January in Bangladesh. So both of map we make the analysis using Google Earth engine, and after that we are just download the data as a TIFF format, and further we can easily make this type of map using ArcMap software. You can also do it the QGIS software also for your research paper or your presentation. Okay, so we also discuss about that also, how we can easily create after downloading the data, how we can easily make the map using ArcMap software. We also discuss about that. So here you can see this is another work for the nitrogen dioxide level rebound in Bangladesh for the different time period. So basically this time we are just make the some classification for level of nitrogen dioxide, very low, low, medium, high, and very high for the different time period. The COVID situation, we also try to discuss about that. And basically in the air quality monitoring, I will try to discuss about that particulate matter 2.5, as well as discuss about the MODIS AOT. Okay, but Sentinel-5, this data set, we provide you the lot of air quality parameters. it can be ozone or nitrogen dioxide or sulfur dioxide or formaldehyde or other methane or aerosol. So this type of gases we can easily access from the Sentinel-5 satellite imagery. And this is the link about that Sentinel-5 satellite imagery. You can simply go to this link and you can easily access all of data set for Sentinel-5. So now just let me open my code editor. We can also access this data set from our code editor also. Okay, so from here you can see about that search place and data set, and click on the browse data catalog. So now we can easily access all of Earth Engine public data catalog. We can easily access from here. So here you can see the Sentinel. Just click on the Sentinel. So now we can get all of Sentinel image collection. And I want to work for Sentinel-5, okay, tropospheric monitoring instrument. So this dataset is available from 2018. Okay, so all of dataset we can easily get it from here. You can see the ozone, then methane, formaldehyde, aerosol, carbon monoxide, nitrogen dioxide, sulfur dioxide. So all of dataset we can easily access from here. And here you can see you can get the two types of data. One is the offline, another is the near real time. Okay, so near real time is the very update data set. Okay, so this is the near real time, and this is the another is the offline. So both of data set we can easily access from here for each parameter: carbon monoxide, formaldehyde, or nitrogen dioxide, ozone, or you can see about the methane or sulfur dioxide. So all of gases we can easily access from here, all of data set. So now I will show you that. Suppose I will show you for the nitrogen dioxide. This same process you can also apply for the ozone or other parameter for the Sentinel-5. So just I click on here. So now it will show you that all of information about that Sentinel-5, Sentinel-5P, mainly nitrogen dioxide. So you can get this type of data. You can see about that data set availability time from this year of 2018 to 2024. This time we can easily get the data. And this data set provided is the European Union ESA Copernicus. And this dataset resolution is that 1113.2 meters. Okay, and you can see about this is the Earth Engine snippet. Okay, this is the unique ID about this dataset. We already know about the Earth Engine snippet because every dataset we find out this type of snippet. Snippet mainly it's a unique ID of your dataset. So now suppose I want to work with this dataset and further I want to monitor the nitrogen dioxide for a specific cities or boundaries or any specific polygon. I want to monitor for the different time what the situation of that nitrogen dioxide. Okay, so first of all just copy this unique ID, mainly snippet ID, copy and then paste on your code editor. Okay, just simply paste. Then you put any name. You can put any name as a variable. Suppose I put the variable name is that dataset. Okay, then equal sign. So now this is my image collection, full image collection, and this image collection I just stored in a variable dataset. And this image collection have a, you can see different types of band. So here you can see first band is that nitrogen column number density. Another is the tropospheric nitrogen column number density. Then stratospheric. So different types of phase we can get this monitoring the nitrogen dioxide. So in this time, suppose I want to work for the density. Suppose I want to find out where is the high density of nitrogen dioxide, where is the low density. So this type of things I want to monitor. So then that's why I just use this band, and this is the unit about that mole per meter squared. Okay, so this band just I copy from here and I want to select. So basically this image collection have all of band, but I want to work for a specific band. So this band I want to select using select function, and then just paste the band name. Okay, so now from this image collection I just select for my specific band, and then I also want to need the data for a specific time period. Suppose I want to monitor the nitrogen dioxide month of January 2024. Okay, so for that I simply put the specific time period using filter date function and put here start date and end date. Suppose I put the date year of 2024, 1st January from year of 2024. Suppose January 31. I take the data for 1 month. So now I want to check how many images are available in my data set. Okay, this variable, how many images are available, I want to check it. So same as just use the print function and call this data set and use the size function. Size function mainly computing how many images are available in a collection. So let's go try to check it. So we find out that 417 images are available in my collection. Okay, so now I want to make the time series chart. Suppose I want to make the time series chart for my specific boundary. Suppose my city boundary, suppose Dhaka city boundary, I want to find out when is the high or low trend. We can easily find out from the time series chart. We find out the temporal changes of the nitrogen dioxide for the different time. So just let me import my study area. Suppose this is my study area. I simply click on here. So I already import my boundary shape file for Dhaka city boundary. So this boundary, now I want to make the time series chart. I want to check what the situation of nitrogen dioxide in month of January 2024 for this boundary. So just import. So now it imported default variable name as a table. So you can put any name as a variable. I put the name as a RY, or you can put any name. Okay. So now I want to make the time series chart. We already know about the time series chart. Okay, this function you need to use. So we have to use the function. This function is the UI dot chart dot image dot series. So this is the function we already know. Just get all of information. So in this function here you can see the first argument is the image collection. So without image collection value we cannot make the time series chart. Okay, always remember that without image collection we cannot make the time series chart. So here you can see I just make the image collection 417 image collection, store it in this variable. So just I simply use it. I simply copy the data set and paste here. And region, it's my study area, my shapefile boundary, which is RY, and this time month of January 2024 I want to check about that suppose average time series chart or average value. So just use your dot mean, then scale, it's your resolution 1113.2 meter, and X property default we are just set here system time start. Okay, and further I just take a variable, suppose chart, and then equal. Okay, so now just print the chart, click the run. So now here again, so we can get this type of chart, but the chart have a problem. This problem is that when I just show the value, suppose you can see this type of value show about that 0. You can see it show about the 0. Okay, unit is the mole per meter square, but this value show as a 0. Okay, you can see 0, but it has a value. This value is not computing now because this is the very big unit, mole per meter square. Okay, so that's why now it show about the 0, but when I convert it into micromole, then we can easily get the value. You can see all of value show as a 0. Okay, because this unit is the mole per meter square. but my value is very, very less. So that's why it show about the round figure as a 0. Okay, but when I change the unit, suppose mole to micromole, suppose I simply search here mole to micromole, you can see about that multiply this value, mainly 1e6 or this value. When you multiply this value, then we can easily get the result mole to micromole. Okay, and when you convert this unit, then we can easily get it this type of value. Okay, otherwise it show about that 0. You can see all of values show about that 0. Okay, because its unit is the mole. Okay, so that's why.
Excuse me.
Yeah, please.
Excuse me.
Yeah,
I have a question here.
yeah.
Now we have collection from satellite around 417 images on this period, on this month. But now in the plot, we can see only around 1, 2, 3, 4, 5. It's just a matter of like 1 point. Is it like an average daily, or how it's plotting this? It's not a time series one, right?
So it show about that each day. Suppose here you can see about that. If you check the image acquisition time, so just simply print the data set, then we also get about that time. So every images we can get the time. This 417 images, we also get this type of time. So here you can see about the feature. From the feature, we can get about that every images. Okay, so here you can see the first image 2024, mainly it says 2nd January. Then you can see about the 3rd January. Here you can see about that. We can get that.
Yeah, but you don't have points. My
Yeah.
question, you don't have 417 points. You have only
Yeah.
30 or 40 points. I don't know why.
So here you can see about that. Oh, you can get the February, March. You can see that it's a time, not day data. It's a time data. Time data means that suppose in March, which time we get the data. Okay. Suppose in the March all time there is no data. Suppose sometime it show about the null data, but a specific time. Suppose for this time you can see that the lot of same date. It's the same date. It show about the same date, but also you can see about the 4. Okay, date 4. We can get this. You can see about the 4. It's the same date. Okay, it's show about the same date because it's a time set data. Suppose for a specific time, for this January, 3rd January, for a specific time we extract the information.
Yeah,
Okay.
but it's plotting only, if I have on the same time 5, 4, 5, it takes the average of the 4 and plot it, because in the plot it shows only 1 point.
Yeah, so basically now, okay, just a minute, I cannot, I just set my microphone, it's not clearly, I cannot hear you, just a minute. Okay, so now it's better, so please again.
Okay, now we have 417 points. If it's a time series one, we should get the graph of 417 points or 17 points on the graph. But now the graph is showing only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So around 20 points, no more. Why I have 417 points plotted only as less than 20? Where are the other points?
Okay, so other points, it also, suppose there is no data. Okay, so I'll open this CSV file, then it will be more better. Okay, so here you can see, so let's check about that last one. Here you can see 417. Okay, so all of images have not data. So that's why it extract the information total between this time period. It get the total 417 images, but all images have not data.
Can we filter this in advance rather than getting false information, rather than saying I have 417 and not 417 are late? How we know that?
So we can get it from our time series chart. So here you can see in this time series chart. So basically when I can get the value, suppose here you can see it have a value. Okay, so further when I convert it micromole, then you get the value. Okay, suppose January 2 we get the value. Okay, so this is my one time or one day. Also you can say about that January 3 I also get the value. Also you can say about that January 4 I can get the value. Also you can say about that January 5 I can get the value. So now this data mainly load for time wise. Suppose every after 30 day or 60 day we can get the data. But when I get this type of things, it show about that one day's average. Suppose in the full one day we can get the data for the 3rd January or 2nd January, or also you can see about that 3rd January. It's a full days, not only for the single. So full days it show the average result. Okay, also you can see about that 4th. So in this time here you can see we can get every single day's data, every single day.
So this day means the average of the
daily average.
If I have
Daily average. Daily average.
yeah.
It show about daily average, but it show about the 0 because it show in the unit is the mole per meter square. So that's why we get the more less unit, so micromole. Then we can easily get all of values, and then we can say it's a daily average time series chart of nitrogen dioxide. Okay, so let's go try to do it. Okay, so now here we are just multiply. So here you can see this is the formula about that. Multiply the amount of this value. Okay, then we can get the result in micromole. And when I convert the micromole, then we can easily get all of values. So for conversion, we are just make a function. So just I write the function in here. Just take a variable. I put the variable name, suppose micromole. Okay, and then just put the function keyword. In this function keyword, I just take the element name img and then put here the curly bracket. In this curly bracket, my argument is that I just multiply. Okay, so just I return this image, multiply this value. Okay, this value, just copy and paste here, and then I apply it all of images between this time. Okay, so just use at the copy properties. So a lot of time we use this type of function, copy properties, and apply this image and apply system time start to system time end. System time. Okay, so now this is the function. Okay, this function mainly calculate convert. Okay, so this is my function and this is my collection. Okay, data set, it is stored in my total collection. So now I just make the connection. So just simply copy this variable and paste here, and then use a map function and then close it. So now this total 417 images is multiplied with this value. So further, I simply copy my final object and make this time series chart and click to the run. So now it get the result in micromole unit. So just click on here. So here you can see you can get this type of value. So here you can see in the January 3rd, we can get the 130.93 micromole. This is the average concentration of nitrogen dioxide. Also you can see about that 327 January 4. Also you can see about all of value now it's appear when I convert the unit. Okay, so you can see about that. Also you can see the high in this time 605 micromole. We can find out the January 21, 2024. Also you can see about that. Okay, so now you can get all of values. Okay, and it show about that daily average result for concentration of nitrogen dioxide. Okay, so first time it not show the value because it's a mole unit, but when I convert into micromole, then we can easily get this type of result. So other gas as the same. So when you try for that other gases, sulfur dioxide or methane or carbon monoxide, then when you face this type of problem, just simply convert the unit mole to micromole, then we can easily get this type of result. Okay. Okay, so this is the time series chart about that. So from here you can easily add other parameters. Suppose just I use here set options, and then further add here the suppose title. Suppose time series chart, and then further suppose I put the v-axis, mainly vertical axis. It's a value. Further suppose horizontal axis, put here that s axis, and put the title is that time. Okay, we have also need to mention here the title. Okay, so now this type of things also added. Click on run. So now here you can see we can get this type of dot sign. Okay, so in this time it's about the dot sign, because other, suppose in the January, you can see here in the January all of images we can get the multiple date, we can get the same images, but all of images have not data. Okay, suppose here you can see the image 1st January, you can see lot of images for the 1st January. Okay, but all of images have not data. Okay, total we find out that 417 images, but it show only for this type of which data is available, it show only for this type of point. Okay, so now if you want, you can also make the continuous chart without line breaking. So you can just simply open the interpolate null, then it also okay. So just put here inter nulls is true. So now click the run. So now here again, so we can get that continuous time series chart, okay, with value. Okay, so it show about that all of values. So this is our time series chart. We can easily get it from here. Okay, so any question about that, you can ask me. Any question?
No, sir.
Okay, thank you. Okay, so now if you want, you can also check about that suppose trend. Okay, suppose for this study area in my Dhaka city, I want to check using this data set. I want to check about that, what the scenario, what the situation, the nitrogen dioxide, it's the trend is the high trend or low trend. Okay, so we can also make the trend line. Okay, so we can get that up line or low line. From that line, we can easily set the decision for this study area day by day, increase the nitrogen dioxide. Okay, so you can also apply this technique also for other time series chart. It can be NDV or any other time series chart. Suppose you want to check about the trend for a specific data set. So now in the nitrogen dioxide, I want to check about what is the trend. This is the uptrend or low trend. For the nitrogen dioxide, uptrend means that day by day increasing that nitrogen dioxide density. Low trend means that day by day decreasing that density of nitrogen dioxide. So let's go in this time we talk about the trend. So for the trend, we are just use a things. It's called the trend lines. So just use here that trend lines. suppose trend lines, this is things, and then put this curly bracket. In this curly bracket, just we are put. So here you can see now we can get only for the one line. Okay, so this is the only for the one line chart. So one line set. So in the JavaScript programming, we already know about that. One is defined as a 0. Okay, 2 is the 1. So 0 is the first item. So in this time in my line chart, we find out only for the one item, mainly one line. So I define it as a 0. After that, I just simply set my all of argument one by one. Okay. So now in the trend line, we can find out the different types of trend type. One type is the linear type. We can also apply for the polynomial or exponential. So different types of trend line is available. So I want to set the type. Suppose I set the type as a linear. Okay, and further, if you want to also set about the color, suppose I want to trend line, I want to show as another color. So for that, just put here the color and set the color as a suppose red color, or you can put any color. Okay, and then if you want to also set the other parameters, suppose line width, so trend line width. So just I put here the line width, suppose I put here 5 pixel or 5. Okay, and as well as you can also set here the opacity. Okay, or visibility or opacity. I set the opacity, suppose 0.2. Further, if you want, you also add the legend. Okay, trend line legend. So for that, just you put here the visible in legend. Okay, visible in legend. Then set the boolean operator true. So now it will show about the legend. So just add this type of things. Any other time series you can also apply when you check about the trend. So now just click the run. So now it also show about that. Okay, so here you can see you can get this type of trend line. Okay, so here you can see this trend line is the up. Okay, so you can see I just zoom the chart. So it shows about that uptrend. Okay, so it means that day by day the nitrogen dioxide concentration or density increase in the Dhaka city. Okay, so you can see about that. So you can get the uptrend. So this is the process. You can also apply for other time series chart also. It can be NDVI or any other time series chart. If you want to check about the trend, you can also add the trend line, and from that you can easily get the decision what the scenario. It will be increasing day by day or decreasing day by day. We can easily get it from here. So this is the process for making the trend line time series chart. When you make any time series chart, you can also take it from the trend line. Okay. Okay, I hope we can easily get this idea how we can easily check about the trend line. So now we talk about that how we can easily visualize this map. So in this time we are just working for the Dhaka city. Okay, so this result for the Dhaka city month of January 2024. Okay, we make the time series chart as well as also make the trend line. So now I want to visualize for the mapping. Okay, so which place is the more density, where is the low density, we can easily visualize when I set the visualization of map. So let's go try to set it. So for doing this visualization, first of all, we need to reduce this image collection. So here we find out the total 417 image collection. So this 417 image collection I need to reduce. And how I can reduce? We already know about that reducer. Mainly, we can easily calculate the average pixel and get the reducer, or maximum pixel and get the reducer, or minimum pixel and get the reducer. So there is a lot of things we can easily apply. Suppose now I want to calculate the average pixel. Okay, so that's why you can easily apply the reducer for average. Just take a variable, suppose NO2, and then call this dataset. Okay, before that, anyone any question, you can ask me. Let me check.
Thank you very much.
Yeah, please.
It's a good question just to get me follow up.
Yeah.
Now, once we are going to the map layer, we can go and do average or present the average map so to get like what is known. But based on your experience, what's the best? This is not only for this, for all the other parameters like LSP or urban Thailand or the air quality. If we need to present or talk about a city or a country, which parameter really can tell us it's good or bad? For example, what are the limits? Can tell us this is a tree, this is not a theme. So how we set these boundaries to show this is like, because you can tell us, but tell us, can give us like red, blue, and anything, but in reality, could be red, but could be good. It's still in a good range. You understand what I mean? How we can do the right band for the parameter?
Okay, okay. So basically, we set the different types of color, and already some color is available for the Google Earth engine for the different types of parameter, such as LST or NDVI. Already have some color or precipitation data. So already available this type of data is in Google Earth engine. So basically, for the map visualization is important in Google Earth engine, but we can download the data. Okay, suppose if you want to work for that any presentation or any research paper, so we can download the data from here, and further we can set the color. And when I download this map, then we don't get any kind of color. Okay, so we need to set the visualization again in our ArcMap software, and then we can make the map. So that's why in this time this visualization is not much important, but already have some color. Suppose for LST, which color is the best, or NDVI, which color is the best, or other parameter, which color is the best, is already available in Google Earth engine. So you can also take this type of color code and also set, then you also get that more better map. Okay. But further, after making the TIFF format, we download the TIFF format. But when I download this TIFF format, then we don't get the color. We can get just only for that grayscale color. Okay. Then we are just import this data in our ArcMap, and further we are just make the map using, we can set the color in ArcMap software or QGIS software and make the final map. Okay. So it's also you can simply get the some color from Google Earth engine for different. Suppose simply search here. Also you can see there also get this type of color here. You can see. Okay, so this color is already available in here. So here you can see in this time they use this type of color combination: black, blue, purple, cyan, green, yellow, and red. So here red is identify about that high concentration. Black is identify about the low. Okay, then blue, then purple, cyan, yellow. So this is the color combination they are using here for this data set. So every data set we can easily find out this type of color plated. Okay, so and when you use this type of color plated, then we can easily get the more better map. Okay. Okay, any question?
Just in case when we export the data or in CSV and so on, or we get the image scale, and then how when we send it to clients, they are just complaining that there is nothing. These colors are not there. Even when we take the layer or whatever, the image from the website, sent to clients as GT or whatever production big scale. So they will not know exactly what's happening inside. So this is how can we sort it out. Only can do this screenshot, but they don't like that because it's not a
Yeah. So that's why we need to set the color also when you work for the ArcMap software. Okay. Or if you want, you can also take the screenshot. Suppose you can add the map and take the screenshot, but it's not a proper way for the research paper. So that's why we download the data as a grayscale, mainly white and black grayscale, and then we set the color from ArcMap software. So I will show you for that today's session. I will show you that how we can easily work with that ArcMap software to set the color. from the arc map, and also make the map layout. Okay, but
Yeah,
in
but
this
the
time,
arc
in
software
here we can
is
get
not
only
free.
for that screenshot and also visualize it. Yeah, please.
The ARC is not free software, right?
Yes, Arc is not free, but we can also use at the cracked version. It also okay, but QGIS is also okay for that. QGIS is open source software. We can easily use the QGIS software and also make the map layout about that. No problem. Okay, no problem. It also available for QGIS. It also work for the QGIS and ArcMap or any other geospatial software where we can easily create the map layout. We can easily apply. No problem. Okay, so I'll show you that for today's session also how it will be work. Okay. So here you can see I already worked for this type of file. So it's downloaded as a grayscale. So further, this grayscale map, we can easily make the map layout or add the color from ArcMap software or QGIS software. Okay. Okay, so let's go on. Okay, so now I'm going to apply the reducer. So just I call this dataset and then paste here. Now I want to calculate the average pixel. So just use the reduce, and how I can reduce, I want to apply the average. So just use EE dot reducer dot mean. Okay, so now it's calculate the average pixel, and then just clip with my study area, which is ROI, and then just display this layer. So map dot add layer of NO. So just click the run, and also center view of this map, center object is ROI, and put here the 10 and click run. So now it's center view of this boundary shape file.